Mars and Its Canals by Percival Lowell, Chapter 4. The Polar Caps. Almost as soon as magnification gives Mars a disk, that disk shows markings, white spots crowning a globe spread with blue-green patches on an orange ground. The smallest telescope is capable of this far-off revelation, while with increased power the figure grows steadily more articulate and full. The 2¼ inch glass, the writer saw them 35 years ago. After the assurance that markings exist, the next thing to arrest attention is that these markings move. The patches of colour first made out by the observer are shortly found by him to have shifted in place upon the planet. And this is not through a mistake on his part, but through method in their phenomena, for all do it alike. In orderly rotation the features make their appearance upon the body's right-hand limb in the telescopic image, travel across the central meridian of the disk, and vanish over its left-hand border. One follows another, each rising, culminating and setting in its turn under the observer's gaze. A constantly progressing panorama passes majestically before his sight, new objects replacing the old, with a march so steady and withal so swift that a few minutes will suffice to mark unmistakably the fact of such procession. But for all this ceaseless turning under his gaze, after a certain lapse of time it is evident that the same features are being shown him over again. With such recognition of recurrence comes the first advance towards acquaintance with the Martian world, for that is all their journeying. Their configuration alters not, proves them permanent in place, part and parcel of the solid surface of that other globe. This surface, then, lies exposed to view, and by its turning shows itself subject, like our Earth, to the vicissitudes of day and night. In such self-exposure Mars differs from all the 4 great planets, Jupiter, Saturn, Uranus and Neptune. Features indeed are apparent on the first 2 of these globes, and dimly on the other 2 as well, but they lack the stability of the Martian markings. They are forever exchanging place. In the case of Jupiter, what we see is undoubtedly a cloud envelope, through which occasional glimpses may possibly be caught of a chaotic nucleus below. With Saturn it is the same, and the evidence is that the like is true of Uranus and Neptune. What goes on under their great cloud canopies we can only surmise. With Mars, however, we are not left to imagination in the matter, but so far as our means permit, can actually observe what there takes place. Except for distance, which, through science, year by year grows less, it is as if we hovered above the planet in a balloon, with its various features spread out to our gaze below. Attention shows these areographic features to be on hand with punctual precision, for their traverse of the disk once every 24 hours and 37 minutes. For over 200 years this has been the case. Their untiring revolutions have been watched so well that we know the time they take to the nicety of a couple of hundredths of a second. We thus become possessed of a knowledge of the length of the Martian day, and it is not a little interesting to find that it very closely counterparts in duration our own, being only 1/35 the longer of the 2. We also find from the course the markings pursue the axis about which they turn, and just as the period of the rotation tells us the length of the Martian day, so the tilt of the axis, taken in connection with the form of the orbit, determines the character of the Martian seasons. Here again we confront a curious resemblance in the circumstances of the 2 planets. The tilt of the equator to the plane of the orbit is, with Mars, almost precisely what it is for the Earth. The more carefully the 2 are measured, the closer the similitude becomes. Sir William Herschel made the Martian 28 degrees, Schiaparelli reduced this to 25 degrees, and later determination by the writer puts it nearer 24 degrees. The latter is the one now adopted in the British Nautical Almanac for observers of the planet. This is a very close parallelism indeed, so that in general the character of the Martian seasons are nearly the counterpoint of ours. In length, however, they differ. First, because the year of Mars is almost double the length of the terrestrial one, and secondly, because from the greater ellipticity of Mars's orbits, the seasons are more unequal than is the case with us, some being run through with great haste, others being lingered on a disproportionate time. It is usual on the Earth to consider spring as the period from the vernal equinox, about March the 21st, to the summer solstice, about June the 20th, summer as lasting thence to the autumnal equinox, autumn from this latter date, about September 20th, to the winter solstice on December 21st, and winter from that point on to the next spring equinox again. On this division, our seasons in the northern hemisphere last respectively spring 91 days, summer 92 days, autumn 92 days, and winter 90 days. On Mars these become, reckoned in our days, spring 199 days, summer 183 days, autumn 147 days, and winter 158 days. If we had counted them in Martian days, they would have totalled about 1/35 less in number each. In its days and seasons, then, Mars is wonderfully like the Earth, except for the length of the year. We should hardly know the difference in reckoning of time, could we some morning wake up there instead of here. Only in one really unimportant respect should we feel strange. In months we should find ourselves turned topsy-turvy. But lunations have nothing to do with climate, nor with the alternation between night and day, and in these two important respects we should certainly feel at home. Though the axis could be determined by the daily march of any marking, and thus the planet's tropic, temperate and polar regions marked out, the process is made easier by the presence of white patches covering the planet's poles, and known in consequence as the polar caps. It is from measures of the patches that the position of the Martian poles has actually been determined. These polar caps are exactly analogous in general position to those which bonnet our own Earth. They reproduce the appearance of the ice and snow of our Arctic and Antarctic regions seen from space in a very remarkable manner. In truth, they are things of note in more ways than one, and would claim precedence on many counts. Priority of recognition, however, alone entitles them to premier consideration. Among the very first of the discs detailed to be made out by man, they justly demand description first. With peculiar propriety, the polar caps have thus the pass. Not only do they stand first in order of visibility, but they prove to occupy a like position logically when it comes to an explanation of the planet's present physical state. It is not matter of hazard that the most evident of all the planet's markings should also be the most fundamental, the fountainhead from which everything else flows. It is of the essence of the planet's condition, and furnishes the key to its comprehension. The steps leading to this conclusion are as interesting as they are cogent. They start at the polar cap's visibility, for their size first riveted man's attention, and then attention at them disclosed that most vital of the characteristics of the planet's surface, change. Just as almost all of the features we note are permanent in place, showing that they belong to the surface, so are they all impermanent in character. Change is the only absolutely unchanging thing, except position, about the features the planet presents to view. It was, in the aspect of the polar caps, that this important fact first came to light. Not only did they thus initially instance a general law, they have turned out to make it, for by themselves changing they largely cause change in all the rest. But for a long time they alone exemplified its workings. To Sir William Herschel we owe the first study of their change in aspect. This eminent observer noted that their varying size was subject to a regular rhythmic wax and wane timed to the course of the seasons of the planet's year. The caps increased in the winter of their hemisphere and decreased in its summer, and being situate in opposite hemispheres, they did this alternately with pendulum-like precision. His observations were soon abundantly confirmed, for the phenomena take place upon a vast scale and are thus easy of recognition. At their maximum spread, the caps cover more than 100 times as much ground as when they have shrunk to their minimum. In the depth of winter, they stretch over much more than the polar zone, coming down to 60 degrees and even 50 degrees of latitude north or south, as the case may be, thence melting until by midsummer they span only 5 or 6 degrees across. In this they bear close analogue to the behaviour of our own. Ours would show not otherwise, were they viewed from the impersonal standpoint of space. Very little telescopic aid suffices to disclose the Martian polar phenomena in this their more salient characteristics and convince an observer of their likeness to those of the Earth. Anyone may note what is there going on by successive observations of the planet with a 3-inch glass, nor is the change by any means slow. A few days at the proper Martian season, or at most a couple of weeks, produces conspicuous and conclusive alterations in the size of these nightcaps of the planet's winter sleep. Resembling our own so well, they were early surmised to be of like constitution, and composed, therefore, of ice and snow. Plausible on its face, this view of them was generally adopted, and common sense has held to it ever since. It has encountered, of course, opposition, partly from the very proper conservatism, but chiefly from that earth-centred philosophy which has doubted most advances since Galileo's time, and carbonic acid has been put forward by this school of sceptics to take its place. We shall critically examine both objections, the latter first, because a certain physical fact enables us to dispose of it at once. In casual appearance, there is not much to choose between the rival candidates of common sense and uncommon subtlety, water and frozen carbonic acid gas, both being suitably white and both going and coming with the temperature. But upon closer study in one point of behaviour, the two substances act quite unalike, and had half the ingenuity been expended in testing the theory as in broaching it, this fact had come to light to the suggestors as it did upon examination to the writer, and had served as a touchstone in the case. At pressures of anything like 1 atmosphere or less, carbonic acid passes at once from the solid to gaseous state. Water, on the other hand, lingers in the intermediate state of a liquid. Now, as the Martian cap melts, it shows surrounded by a deep blue band which accompanies it in its retreat, shrinking to keep pace with the shrinkage in the cap. This is clearly the product of the disintegration, since it waits so studiously upon it. The substance composing the cap, then, does not pass instantaneously or anything like it from the solid to the gaseous condition. This badge of blue ribbon about the melting cap, therefore, conclusively shows that carbonic acid is not what we see, and leaves us with the only alternative we know of, water. End of chapter 4.